Okay, welcome to lesson 13. This is going to be part 1. So part 1 is going to be dealing with proper fractions. So we need to remember what proper fractions are. This is going to be part 1. So proper fractions, first of all, a fraction is where you've got part of a whole. That's what a fraction actually is. It's showing part of a whole number. Now, they're used in lots of daily activities and expressions. For example, you might say, oh, it's a half hour till the bell rings. Or we might say there's a quarter of a pizza left. Or it's quarter past the hour. All of those are fractions. Fraction shows up with a top number and a bottom number. Now, the top number is known as what's called your numerator. And the bottom number is your denominator. So that's how a fraction's created. Now, a proper fractions means you have a small number on top. A small number on top of a big number. That's what a proper fraction is. So example, 4 out of 5. 4 is smaller than 5. So 4, it's in a proper fraction, meaning the top number is smaller than the bottom. So if we take a look at the pictures, there's many ways we can describe fractions. One way is using pictures. So when we look at this picture, it says this shape has 4 equal parts. So they made a square, okay, so it's a square, and it's got 4 equal parts. One part is shaded. So what we've got is we've got the shaded on top of the whole. Okay, so how many of them make up the whole object? Well, 4 of them make up the whole object. Okay, and since 4 of them make up the whole object, 1 of them is shaded. So that's what's going on with that. All right. Okay, so now if we look at the example on the right, the second example, we see a shape. This is a rectangle, and it is divided into 8 different parts. So they divided it into 8 parts, and they shaded 3 of them. So we've got the shaded out of the entire amount of parts, okay? So other examples of proper fractions are when you've got small numbers over big. So I could put the number 99 over 1,000. Small number on top of big number. So again, they're showing us what the numerator and denominator are. So again, the numerator, that's how many parts of the whole you're talking about. And the bottom is the total number of pieces that your item is divided into. So this is the total number of pieces. So total number of pieces that you've divided something into. And then the other part on top is the part you're talking about. It's the part you've selected. So now we're going to talk about mixed numbers and improper fractions. So when we look at part 1 here, we're talking about the 3 different types of numbers you get with fractions. So the first kind was a proper fraction, small number over big. Then we get what's called improper fractions. This is the opposite. This is where you're going to get a big number on top of a small number. That's the difference. Okay, so that's the difference between improper and proper. So improper means they've flipped it upside down and they've got the big one on top. Okay, that's what's going on with that one. Now, a mixed number means that you've got more, you've got whole parts. So mixed numbers mean you've got more than one whole part. So if you've got more than one whole, you'll have items that are completely shaded. So if we look at the example on the bottom here, we have 3 identical objects, 3 identical rectangles divided into 4 shapes. Okay, they're divided into 4. Here they've got all of it shaded. Okay, they've got all shaded for both of those. So that means we have 2 wholes. So this is saying 4 out of 4, which equals 1. This is 4 out of 4, which equals 1. If you take 4 divided by 4 on your calculator, you'll get 1. That's 1 whole. That means all 4 parts of that are shaded. So I could do it as well with a piece of pizza or a pie. I could divide it into 4 pieces. And if I shade all 4 pieces, that means I ate the whole darn thing. Okay, I ate the whole pizza. That's what that's talking about. So if we consider these, maybe we ordered rectangle pizzas and we ordered 3 pizzas. How much would we have left over out of 3 pizzas? Well, we ate 2 big whole ones, so we ate these guys. They're gone. So we have 2 wholes, and then we have 1 out of 4 shaded. That's how many is left over. So this is called the leftovers. Okay, so the fraction part of your mixed number is the leftovers part. All right, so let's look at the top of the next page where it says, in total, 9/4 are shaded. So 9 parts out of 4 are shaded. They're talking, this here is talking about that example. Okay, so they're saying 9 squares out of how many possible? 12 are shaded. So 9 out of 4 are shaded. So how can I change 9 over 4? Well, 9 over 4 is the same as me saying 2 and 1 over 4. It's the exact amount that's shaded. So these are identical. And you could say it the same way. So I could say I ate 2 pizzas and 1 piece from the other pizza. Or I could say I ate 9 pieces out of 12 because there's a total of 12 pieces. How do we know that? Because there's 4 pieces, 4 pieces in 3 pizzas. So in the 3 objects. Well, that means I have a total of 12. So I have a total of 12 pieces of pizza that I could be sharing with everyone, right? So that would be 12 total. I ate 9 of them. Okay, so how many would be left over that are not eaten? You would say 3 out of 4. So I would say 3 out of 4 are left over. Okay, that's the not shaded. This stuff is not shaded. All right, so it says impropers can be shown as mixed numbers. That's what I showed you there. So we can represent them as a mixed number with our wholes and our part, or we could say how many pieces total. So for example, I've got this one right here. Again, I've divided my objects into 4. So I've got 1 whole, 1 whole, 1 whole. That gives me 3 wholes. Okay, so 3 entire big pizzas. Now, after the 3 wholes, okay, what do we have left over? I've got how many pieces left? I've got 2 pieces I ate out of 4. That's how many I ate. So I ate 3 whole pizzas and 2 pieces out of 4. That's what that's telling me. Count all of the pieces. So if I were to count all my pieces, I've got 4 here, 4 here, that's 8. I have 4 more, that's 12. So I've got 12 plus 2 more is going to give me 14 pieces shaded. Okay, so 14 pieces shaded is going to be the same thing as this. 14 out of how many each object? This is per object. So the number on the bottom is not out of 16. The number on the bottom is out of 4 because each object is out of 4. That's why it's out of 4. Okay? So if we convert these to decimals in our calculator, we would type in 2 divide 4. I would get 3.5. Now, if we all try on our calculators and we go 14 divide 4, we're going to get the same answer. We're going to get 3.5. So those are called equivalent, meaning they're going to be identical answers. Okay? One last example here. So here's our example. It's continued on the top of page 3. So the bottom of page 2 here, it says we have 4 identical shapes. These guys are now divided into 9 parts. So there are 9 parts for each object. Okay? So that means 9 is the bottom of my fraction. Okay, so 9 is the bottom of my fraction. So 9 parts for each. That becomes the bottom. Okay. Now, the top number is the amount that are shaded. So the top is the number shaded. So now if we count, I would have 9, 9, 9, and 4. So I'd have to count how many are all shaded. So I'd have 9 plus 9 is 18, plus 9 more is 27. I'd add 4. So 27 plus 4 is my 31. So I've got 31 shaded out of those objects, okay? Out of 9 though. So 9 because one object is divided into 9 parts. That's why the bottom is a 9. So we've got one whole. This is considered one whole. That's where they're getting this number. Everybody look up here, please. They're getting this number right here, one whole, because that's one whole. Okay? This is all shaded. There's another one whole. Entire shaded, another one whole. And then you put the amount shaded out of 9, 4 out of 9. So now we've got 3 wholes and 4 left over. This is the leftovers. And then you slide the numbers side by side. So we slide the numbers side by side, and it's going to look like this. 3 and 4 over 9. Okay, so that's how you end up making it look the same. So this is the improper fraction because it's got a big number on top of a bottom small number. Okay, that's the difference. So improper fraction and a mixed number. So now in my calculator, if I type this in, so in my calculator, I'm going to type in 31 divide 9, and I'm going to get a decimal number. And I'm going to see what decimal I get. I'm going to get 3.4 repeating. Okay, so everybody practice, type that in, go 31 divide 9. You should get 3.444444444. Okay, so type it in, 31 divide 9. Everybody should get that.
Ooh, that's not appropriate.
Okay, now we're going to look at this letter C here, the next example. How many whole objects are shaded? I've got one hole right here, one hole right here, one hole right here. So that's 3 whole objects shaded. Now, how many are shaded total in those?
21.
6 plus 6 plus 6 is our 18. Plus 2 is 20. 18 plus 2 is 20. So I have 20 total shaded. Okay, as a mixed number, my whole goes first. How many are left over? This part is my leftovers right here. This is the leftovers, which is going to go right here. So I have to put that as a fraction. How much is shaded in that last object? 2 out of how many squares? Out of how many squares in that one? Good. So 2 out of 6 squares are shaded in the leftovers. Okay, 2 out of 6. That should be a 6 there. That's what this one is telling us right there. Now, if I count, each object there is divided into how many parts? 6. So that would be my bottom. So now if I type in the numbers, 20 divide 6, to get a decimal, you're going to get 3.3 repeating. So type it in. You should get 3.3 repeating.
I'm sorry.
So in this next example, I see one whole entire shaded, one whole shaded. So that's going to give me 2 entire objects shaded. Now, what is each object divided into? How many squares? If we count them, they're divided into 9 squares each. Okay? So if they're divided into 9 squares each, now I got to find out how many are left over. So this guy is the leftovers. So how many are shaded in that last object? So how many are shaded in the last object? 3. So you're going to put 3 over 9. Okay? Now if I'm going to do it as an improper fraction, we know our bottom number stays a 9. And now I got to count totally how many are shaded. So I would say there's 9 shaded here, 9 shaded here. So we're counting all the shaded. So I've got 9 plus 9 plus 3. This is all of our shaded parts. And this is going to be the top number of my improper fraction. It's going to be that top number. So how big is 9 plus 9 plus 3? That's going to give us
21.
21. Good job. Mental math. Awesome. Yeah. Okay, so that's going to be a 21 divide 9. So now I want everybody to take 21 and divide it by 9 and see what we get for a decimal. 21 divide 9. Let's get our decimal number. That should give everybody a decimal of 2.33333. It's going to be a repeating decimal on this one. So it's going to be 2.333. Okay? So top of page 4, that's what this is all talking about. We wrote all of that on the bottom of page 3. That's what that's all about. Okay? So now we're going to the middle, to the bottom of page 4. Middle, bottom of page 4. Okay? And now we're going to talk about number lines, because we can actually use number lines for mixed numbers. So I'm going to show you how a number line would work for mixed numbers. So what you do is each space between 2 digits is divided into parts of the bottom number of the fraction. Of the fraction. So when we're doing number lines, the amount of spaces between 2 whole numbers is going to be the amount of spaces on the bottom of your fraction. So this number right here has a bottom number of 5. That means there's going to be 5 spaces between each number. So if I start at 0, we would count like this. 1, 2, 3, 4, 5. There's 5 spaces between. Okay? So that's what that's telling me. So if I want to go to 1 hole, I have 2 holes, I have 3 holes. Now it says I have 1 over 5. 1 over 5 means I'm going to go to the first tick past the number 3. What if that number on the top of the 5 was a 4? Where would I draw my line to? Would I draw it right to the 4?
Yes.
If my top number is a 4?
Yeah, no.
What do you think? If my top number, if I've got 3, if I have 3 and 4 out of 5, so my 3 would end here, where does the 4 over 5 go? Am I going to be going all the way to the number 4? Is that what 4 out of 5 means? No.
Go back.
I start here at the number 3 and I count 4 spaces. So I'd count 1, 2, 3, 4. So this guy is going to be located right there. That's where he would be located. Okay? So the 4/5 means he's 4 spaces past the number 3. That's what that's saying. He's 4 spaces past 3. Okay? Right here, this is saying he is 1 space past the number 3. That's what it's showing me. So now what we're going to do is I'm going to show you how to do another one. We're going to do one more together. So I'm going to draw another example. Here's another example of a number line. So I'm going to put my number 0, and I'm going to put a 1 there, and a 2 there, and a 3 there. So the first thing we want to do is we want to count the number of spaces between each number. So if I count my number of spaces, I've got 1, 2, 3, 4 spaces. 4 spaces between. That means the bottom of my fraction is going to be a 4. That's what that tells me. So if I've got the fraction, here's my example. If I've got the fraction 3/4, I'm going to start here and count 3 in. 1, 2, 3. This is where I would draw that fraction. That would be 3/4. Okay? Now, what if I had the number? So I'm going to call him A. We'll call him A. Now we're going to do B. Where would I find 2 and 2/4? Where would B be located on there? So think of the whole number as like you're running a race. So I have to pass this number. So I have to start at 0, and I got to run past the number 2. So I'm going to get to the number 2 and stop. And then I'm going to go how many spaces past the number 2? It's the top number. So how many spaces past the number 2 do I have to go? 2 spaces. So we're going to go this guy right here for B. I'll use a different color for him. So I'll start here. We're going 1, 2. There's my 2 holes. Now I got to go 2 spaces after. So right there, that's where my letter B would be found. He's exactly halfway between the number 2 and the number 3. Okay? Because 2/4 is exactly half. Okay? Now, what happens when we compare them? If I want to say who's bigger, you could do it 2 different ways. You can draw a picture and shade it in. So here, what I would do is I would draw 2 circles. I would chop them into 4 pieces. And now I would shade in the amount that the top number tells me. So here, I would shade in 3 pieces. And here I would shade in 1 piece. Which one has more pieces shaded? The guy on the left has more pieces shaded. Okay, so we have more shaded, so he's bigger. That's why the alligator mouth is opening this way. He's eating the bigger number. Okay, so again, you can show it in pictures. So if I were doing the next one, I could show it in, again, 2 circles. This time I'll divide it into 5. There we go. 1, 2, 3, 4, 5. There we go. Okay, so I got 2 divided into 5. So now what we're going to do is we shade them. So this guy's got 4 shaded. This guy has 2 shaded. So who's got the bigger amount shaded? This guy's got the bigger amount shaded. So he's going to open his mouth to the bigger number. Okay, so that's how we compare them. So again, if you need to draw the object to see it, then you can. All right. Again, when we're doing mixed numbers, the first thing you want to do is look at the first digit. Look at the whole number. So the first thing is compare whole numbers, big numbers. Okay, so compare the large whole number. So you want to see who's bigger of that whole number. Okay? So which one is going to be bigger? So I've got 3 in front, and here I've got 2 in front. Well, which number is bigger? 3 is bigger than 2. So this guy is bigger. Yes?
C's the biggest.
C is the biggest? Well, we're comparing numbers on each one. Yeah. So whenever you see 2 numbers, you're comparing the 2 of them. So right now, what I was comparing, I'll just show you, I was comparing this one to this one. Okay? The next one, I'm going to compare this guy to this guy. So I'm going to hit play again. Everybody look up. If we take a look at the blue ones I've highlighted, again, we're going to look at that big number, a 5 and a 4. We're looking at the 5 and 4, and we're going to say, who's bigger? I'm looking at 5 and 4. 5's bigger, so I'm going to circle 5. So for letter C, now look at what happens. In letter A and B were easier because the numbers in front were different. If the numbers in front are different, it's easier. You just pick the bigger one. But if the numbers in front are the same, then you got to look at the top of the fraction. So these numbers are identical. So what I'm showing you is 5 and 5 are identical. So now I can't look at those numbers. I got to look at the top of the fraction. So which number, top of the fraction in yellow, is bigger? 5 is bigger than 3. So that's why this one is bigger. Okay, because we're comparing the top number. 5 is bigger than a 3. All right. How do you know if something is in a mixed number versus in an improper fraction? The easiest way, equals convert to decimals. Convert both numbers to decimals. Please write this down. To decimals. Okay, so we convert to decimals. So the first thing I'm going to do is I'm going to type in 29 and divide 8. 29 divide 8 is what I'm going to type in. Equals 3.625. This guy I know starts with a 3 in front of the decimal. The big number is always the number in front of the decimal. So now I just have to do 3 divide 8. And that's going to be my decimal number. So if I go 3 divide 8, I get 375. So now I'm looking at the number after the decimal because both decimal numbers start with a 3. Okay, so everybody look up here, please. Both numbers start with a 3, so I can't look at that number. I look at the very next number. So now I'm going to look at the 6 and the 3. Whichever number is bigger between the two, that's the digit who's bigger. So 6 is bigger, so this guy is bigger. Okay, but 6 is bigger than a 3. Okay, last section for this lesson. We need to convert mixed numbers to improper. This is the last section. So converting to improper. These are your steps. The process, these are your steps. So step 1. You've got 4 and 1 over 3. It says multiply the bottom number by the whole number. So I call that looping. I want you to loop it and multiply. So here you're going to go 4 times 3. Okay? Then immediately you're going to add the numerator to your answer. So you're going to add the top. So my top is a 1. That's my top number. So I'm adding the 1. So now instead of a 12, I have a 13. So if we take a look, this is my number 13 right here. Okay, it becomes my top number. The bottom number is the number that never changed. It stays the same. So it says keep the same denominator. So it takes 3 steps to get your top number. Top number. It takes 3 steps to get your top number. The last step is your bottom number doesn't change. It stays the same. So when you convert, how do you know if you did it right? How do you check your work? You check your work by converting both numbers to decimals, and the decimals have to be identical. So convert both numbers to decimals,
The numerator.
and the decimals must be identical. The decimal answers must be identical. So I'm going to take 4. I know my decimal number starts with a 4, and then I'm going to go 1 divide 3. 1 divide 3 gives me 0.3 repeating. So the guy on the left is going to give me 4.3 repeating, and here I'm going to go 13 divide 3, and I'm going to get 4.3 repeating. So my decimal numbers are identical. I get 4.3 repeating is the same as the other guy's 4.3 repeating. That's how you know you did it right, because your decimals are identical. So that's how you know you did it right. Okay? Turn your page. We've got one last. We're going to do the opposite. Now we're going to convert improper to mixed. So now we're just going backwards. Okay? We're doing the exact opposite. Last example. Okay, and now we're going backwards. We are going to convert impropers to mixed. Here we go. Okay, last example. We're going to convert. We're going backwards now. So what happens? Here is your process. Step 1. So we have steps. Step 1. It says take the top and divide the bottom. So we go top, divide, bottom. I'm not pausing again. You need to be quiet, please. So we're going to go 17 divide 4. And we're going to get the number 4. We're going to get 4 decimal, a whole bunch of numbers, okay? What we want is the whole number in front. So we want that 4. That's the number that we keep, okay? So we've got the 4. That's the number we keep. So we keep the 4. So we have a giant 4 now. So now we need to know the fraction. Now the bottom number stays the same. So our bottom number is going to be a 4. Okay, so there's our bottom number. So I have a big 4 and I have a bottom 4. So now what we have to do is we have to times those two numbers. So those two numbers, now we times them. So I'm going to take 4 times 4, and I get 16. So now I'm going to take my top number. We're going to take my top and subtract 16. And that's going to give you your leftovers. Okay, that's going to give me my leftovers. And now my top is 17. Subtract 16 is going to give me 1. So I'm going to end up with a 1 on top. And that's how I end up with 4 and 1 over 4. So again, how do you check your work? You check your work by using decimals. Okay, so you're going to convert both to decimals. So you're going to convert both to decimal numbers to check your work and make sure you did it right. Okay, we're going to do one more. We're going to do one more example with a picture, and then that is the end of this lesson. Okay, our last example for part 1. This is now using pictures to convert into fractions. So this is showing me 3 holes. These are my whole entire shaded object. And then I've got an object divided into 6 pieces. And I've got 2 shaded. Okay. Now I want to convert that to an improper fraction. So to convert to improper, you're going to loop. These 2 multiply. So I'm going to loop these 2 numbers. I loop them and multiply. So that's going to give me 18. Now I'm going to add the 2. And that's going to be my top number. So now my top number becomes a 20. So my top number will be a 20. My bottom number slides over and stays the same. And that's all there is to it. Okay? This concludes part 1 of our fraction lesson.